we see the hybridization, geometry, bond angle, as well as the how the carbon hydrogen sigma bond as well as the pi bonds are going to be formed during the overlapping. So in case of the alkene, so this is one of the representative example of the alkene, which is the ethylene. So ethylene, in which carbon-carbon double bond which is going to be formed, so it will be the sp2 hybridization. So if it is a sp2 hybridization, this bond angle will be the 120 degree, and for sp2 hybridization of the carbon atom, the geometry will be the trigonal planar. So this is going to be for the ethylene molecule, and that means hybridization of the carbon atom, both the carbon atom will be the sp2, whereas the bond angle will be the 120 degree because it is a trigonal planar geometry and sp2 carbon atom is there. So this is the geometry which is the trigonal planar, and in our next slide we are going to be discuss about how the carbon-carbon single bond, carbon-carbon pi bond, carbon-hydrogen bonds are going to be formed during the overlapping. So this is the example for the ethylene. Here we are going to be easily observe that this is the carbon-carbon double bond is there. So if it is a carbon-carbon double bond, so it is going to be carbon atom is going to be show the sp2 hybridization. Another carbon atom will also show the sp2 hybridization. So these 1, 2, 3, 4, 5 are all the sp2 hybridized orbital, in which this is sp2 hybridized orbital 1, this is another sp2 hybridized orbital, and this is the third sp2 hybridized orbital. So the lobes which are going to be shown into the black, which is the empty p orbital, which is going to be remain as it is during the sp2 hybridization of the carbon atom. So in case of the carbon-carbon single bond, in case of the carbon-carbon single bond, which is the sigma bond, so out of the double bond, one is sigma, one is pi bond. So sigma bond between carbon-carbon will be formed by sp2 hybridized orbital of p1 carbon atom and sp2 hybridized orbital of the another carbon atom. So as we have discussed it here, so sigma bond will be formed by simply overlapping of sp2 hybridized orbital of one carbon atom and sp2 hybridized orbital of the another carbon atom. Now a carbon-carbon pi bond, so out of this double bond, one is sigma, one is pi. We have seen how sigma bond is going to be formed. Now we are going to be discuss about how the pi bond is going to be formed. So during sp2 hybridization, one of the p orbital will be remain empty, so which is the perpendicular to the all other three sp2 hybridized orbital. So one empty p orbital of one carbon atom and another empty p orbital of the another carbon atom will be overlap. So there is, in case of the pi bond, overlap will be on upper side as well as the below side also, so of the plane. So there is a formation of the pi bond by the empty p orbital of one carbon atom as shown in the black and empty p orbital of the another carbon atom. So there is overlapping from at the above the plane as well as there is overlapping below the plane, and this bond will be called as the pi bond formation. This bond will be called as what? Pi bond formation. Whereas a carbon hydrogen, so there are the CH2 CH2, that means 4 CH bonds is there. So all 4 CH bond will be formed by, this is the sp2 hybridized orbital of carbon and this is the s orbital of the hydrogen. So carbon hydrogen sigma bond will be formed by sp2 hybridized orbital of carbon atom and s orbital of the hydrogen atom. So this is how shape of the alkene will be described by using the hybridization. So if you are going to be see bonding in ethene molecule, so this will be like this one. So this is also the same that we have discussed into the previous example also. Carbon-carbon sigma bond by sp2 of carbon and sp2 of another carbon. Pi bond will be formed by the empty pz orbital of one carbon atom and empty pz orbital of the another carbon atom as shown into the black. So this is the pi bond formation, whereas CH bond will be formed by 4 CH.